Now we move on to Advitech, whose presentation explores how AI-enabled digital technologies are enabling or advancing environmental performance and decision-making. Let's welcome Clayton Sparke, lead scientist for digital environments. Clayton.
G'day everyone. This is by far the fanciest room that I've ever spoken in front of. But fortunately I went through the innovation mentoring program last year with Osmine and Marianne Cummings, so that has given me the thin veil of confidence that I need to get up here today. So a little bit about Advitech. We'll change the elevator pitch a little bit, given the reflections on the conversations we've had this morning. So we're an SME of SMEs. So we're a small to medium enterprise full of subject matter experts. We have capabilities in science and engineering, also digital and AI, but we have the experience to know when to wield those tools, when it's appropriate. We only do that when it will add value to customers rather than just adding complexity. So the title of today's discussion is Advances in Environmental Management. That's because Clayton's reflection on 20 years in environmental management in the Hunter Valley seems a little self-indulgent. The hero of this talk, unlikely hero, is a textbook that was required reading back in the early 2000s at the University of Newcastle. Yes, the author of the textbook was a lecturer, but I'll let that slide because there was a really interesting chapter focused on, I guess, what was state-of-the-art in mining and extractive industries in the Hunter back in the early 2000s. The reason for dragging that up is it provides us, I think, a really interesting benchmark to look at, well, what is state-of-the-art now? And how much innovation have we actually achieved in the last 25 years. I didn't realise it at the time, being a student at the University of Newcastle, I was already part of the MET's innovation ecosystem, and in the space of 12 months or 2 years, I went from learning about state-of-the-art to actually participating in it. The photo on the right there is 2006, installing real-time noise monitoring equipment at the Mount Owen mine. So in the early 2000s, the industry really raced to embrace this idea of remote environmental monitoring. Part of the reason for that was that noise monitoring would be put into the field for a few weeks, would be brought back by a person and processed, and about 6 weeks after something occurred, we learned about it, which meant that it was really impossible to do any management and intervene in the noise impacts that might be affecting our communities. So Advitech and its partner companies were among the first to commercialise and I guess implement real-time remote noise monitoring at scale, which seemed like a really good idea, and our mining industry partners were really excited by the idea. Xstrata, now Glencore, in about 2010 basically said, yes, this is how we're going to do things moving forward. We're not really sure of where it's going to take us or what the risks might be, but we're going to do it. Those risks, I guess, became apparent fairly quickly when we started streaming data live to people who weren't noise experts and didn't know how to respond to that. They obviously got overwhelmed, and I think, as Leah mentioned, you end up with this decision fatigue and the inability to know what's important and what to respond to. The way that we collaboratively work with our partners to solve that was to counterintuitively actually throw more data at them. So we built the ability to stream audio and do directional noise monitoring and all sorts of other really interesting things. But it wasn't until about 2015 when we first, I developed an interest in machine learning. Everything I'll talk about today is actually machine learning, but AI is easier to say. So we started dabbling in AI around to automate the process of classifying the sound that we were measuring and serving that as an additional data point to the users of these systems to help them make better judgments about what action they might need to take. So if you can imagine, some sites are getting 10, 15,000 alerts per year saying, hey, it's noisy, you need to do something about it. Our goal was to, I guess, cut through the initial bit of the false positives and say, well, yes, the noise is really loud, but that's because there's cows in the paddock next to where you happen to be measuring. So that was quite innovative back in 2018. That was our first publication around that. We immediately realised that we could do better, and that just letting our customers know that there is mine noise or there is not mine noise in this sample wasn't enough. It wasn't cutting through enough. So the ambitious goal that we set was actually, can we identify everything that's making sound in the sample and then actually quantify that in some way? Now, initially, our goal was, I guess, just to emulate the human experience. If we listen to something, we can hear two different noise sources and we can say this one's louder than the other. That was our initial goal. But through partnership with the University of Newcastle, we did work on this over a couple of years, which resulted in some peer-reviewed research and thesis publications. We actually worked out we'd actually quantify the sound pressure level of individual sources, something that approaches the accuracy of someone who has a little bit of experience in noise management. So that's quite exciting. So what that enabled us to do is, pun fully intended with this slide, we cut through the noise, obviously. We can identify what's making all the sound, and it also allows us now to cut through all the noise in those busy dashboards that we were presenting. So previously we might have been serving 10 or 15 different data points to a user and then encumbering on them to make a decision about what all that means. We can actually kind of let all that fade into the background now, and our AI can iterate over that and actually quantify and tell them about the noise source that's important to them. So obviously in the mining sector, we're talking about measuring 2-3 kilometres away from a mine, so we're not upsetting one of our neighbours. They want to know what the mine noise is. They don't care how much sound there is, what the total environmental sound level is, because that's not what they're obligated to manage. So I guess the thing that would be of interest to a miner, an environmental manager, or someone in an operations or control room is the purple line on this chart. We can just cut through everything and say, this is the thing, this is the one thing that you need to be interested in. That's where your attention needs to go. A happy byproduct of the process, the way that we've built that, is we actually have knowledge of a whole bunch of other sources that are making sound. So someone mentioned earlier that to be sustainable supply chains in mining, we actually want to be able to build technology and then export that to other industries. And I think this is a really great example of how that can happen. So we have massive data sets that explain how much train noise or traffic or aircraft noise there is, and we now have the tools to be able to analyse that at scale. So one of the roadblocks that we hit early on was, I guess, first of all, we were serving data rather than information to people, and we're giving that to people who didn't have the same expertise that I had or other environmentally trained people had. And we're also relying on analysis tools that sat outside of that data sharing ecosystem. So we've done a lot of work over the last couple of years to actually go, okay, we're using completely new ways of monitoring, doing environmental monitoring now. We actually need new ways of analysing that data. So we've built these digitally native tools that actually we can give these to our customers. Someone in a control room can use this when they get an alarm. They can bring the audio in, listen to it, tag it, go, yes, that's a barking dog. Calculations in the back end exclude that and allows them to recalculate what the mining contribution, the bit they're interested in, is, and then obviously generate reports from that. The other thing that this does, which I think is important, and someone this morning mentioned trust. So we can actually re-inject the outputs of our AI into this tool and let people see how it's behaving. So it is effectively a black box tool in the way that it's learned. But we think that it's important that people can share in the outputs and actually understand it and make sure that the AI is telling them something that's consistent with what they're hearing, because otherwise they won't believe it and trust it. So in the last 20 years, I guess the mining sector has really set the standard for how noise management in particular is done. So we now have this integrated capability stack where we can put equipment in the field. It will automatically measure data, it will automatically move data, it will automatically analyse data, and then it will just serve the information back to the customer. And again, touching on the point earlier about being able to export that and show that I guess mining is a member of the community, and the technology that mining develops can be shared and benefit other sectors. I guess I'm starting to field questions from people in urban planning and land management and ecologists now, the very same questions that the miners were posing 20 years ago. Going, oh, it's really great, we put all these devices in the field and they record sound, but we don't find out about the thing until 6 weeks later, and I need to know about it sooner. Can you help? So acknowledging that, I guess the mining sector has some unique requirements around the types of equipment that are used. Noise monitoring is done for statutory or regulatory reasons. that's not going to necessarily be required in other sectors. So we're looking at how we can develop some new sensor kits that take advantage of that capability stack that actually are more palatable to other industries outside of mining. So I guess to sum up, 20 years in, how has the state of the art changed? Remote data collection is now normal. That is the new state of the art. That's just how things are done. We have the ability to then automate that data at scale, which has been a constraint for a long time, which I believe will help other sectors uptake this technology with less barriers. That is it for me. Thanks for listening. I really appreciate your time.